You've been lied to your whole life. Since childhood, the first time you looked up at the night sky and saw billions of shimmering lights, you've been told the same beautiful fairy tale. Books, movies, comics, and even the news repeated it. They told you that space is our next home, that stars are new lands waiting for their Columbuses, that humanity was born to spread across the Milky Way, build cities on Saturn's orbit, and watch sunrises on planets in the Alpha Centauri system. We grew up on Star Wars and Star Trek. We're used to seeing spaceships pierce space in a hyperdrive jump, turning stars into blurred lines of light. We watch presentations by Elon Musk promising us Mars, and it feels like it's just the beginning, that in just a little bit, just a couple more decades, we will break out of our cradle. But that is a lie, a great, sweet, soothing lie. We are not explorers. We are not conquerors of the galaxy. We are prisoners. We are locked in the most secure prison in the universe. And the walls of this prison are not made of concrete and steel, but of emptiness, time, and laws of physics that cannot be broken. We live in solitary confinement, and right now, I will prove to you why we can never, under any circumstances, get out of it. Look at Voyager 1. It is the fastest, most advanced, and most distant object humanity has ever created. We launched it in 1977. For almost half a century, it has been flying away from Earth at an insane speed, 17 kilometers per second, 61,000 kilometers per hour. That's faster than a bullet, faster than any fighter jet. In these 50 years, generations have changed on Earth, empires have fallen, the internet appeared, the climate changed. But Voyager just kept flying and flying, in absolute silence, through the icy darkness. And do you know where it is now? Do you think it's already at a neighboring star? No. On the scale of the universe, it hasn't even stepped off our front porch. If you imagine the solar system as a huge city, then Voyager, after 50 years of flight, has barely reached the gate of its own backyard fence. It is still here. It is still under the influence of our sun. Light traveling from it to Earth takes less than a day, but light from the nearest star takes 4 years. Think about that gap. 50 years of flight at the limit of our capabilities versus a single light day. We are snails crawling along a razor's edge, and we think we are running. The problem isn't that we have bad engines. The problem isn't that we lack funding. The problem is how the fabric of reality itself is structured. The universe is not designed for travel. It is designed for isolation. Distances in space aren't just kilometers. They are barriers that are insurmountable for a biological species that lives only 70 or 80 years. We are trapped in the sun's gravity well, and every step outward requires exponentially more effort. You might say, but science doesn't stand still. We'll invent warp drives, we'll open wormholes, we'll cheat physics. But you can't cheat physics. The universe is indifferent to our ambitions. It has hard limits. The speed of light isn't just a number on a speedometer that you can exceed if you press the gas pedal harder. It is a wall of causality. It is the maximum speed of information transfer in reality. And the closer we get to it, the heavier our ship becomes, the more energy is needed to accelerate it, even a millimeter per second faster. We are in a trap. And this trap is multi-layered. Just when we think we've overcome one obstacle, a new, even more terrifying one rises before us. First, distance stops us. Then the Tsiolkovsky rocket equation chokes us. Then, interstellar radiation kills us. And if we miraculously survive, our own biology and psychology will finish us off. The first wall of our prison is scale. The human brain cannot, is physically incapable of, comprehending the real size of space. We evolved on the African savanna. We needed to know how far the lion was, where the fruit tree grew, and how long the walk to the river was. Our concepts of far are limited to thousands of kilometers. A flight from New York to London seems like a long journey to us. But in space, the concept of far doesn't exist. There is only infinite. Let's try to break your perception. Forget about kilometers. Those numbers with zeros won't tell you anything. Let's build a model. Imagine the sun is an ordinary orange. Place it on a table in the center of Times Square. If the sun is an orange, then Earth is a tiny grain of sand orbiting it at a distance of 10 meters. You wouldn't even see it if you stepped a few paces back. Jupiter is a cherry pit 50 meters away. Pluto is a speck of dust 400 meters from our orange. Our entire solar system, our entire home with planets, asteroids, and comets, fits into a few city blocks. Now, a question. Where in this model is the nearest star? Proxima Centauri? In the next building? In the suburbs? In another state? No. If the sun is an orange in New York, the nearest star is another orange lying in San Francisco. Between these two oranges are thousands of kilometers of emptiness. In this model, there is nothing. No air, no ground, no landmarks. Only void. And we, humanity, with all our rockets, probes, and ambitions, have moved away from our orange in this model by only 0.5 millimeter. Do you feel that horror? We are not conquering space. We are crawling in the peel of our own orange. But that's just the beginning. We are used to thinking that the solar system ends at Pluto, that once we fly past the last planet, that's it. We are in interstellar space, free as birds. That is a mistake. The solar system is not a plate with planets. It is a giant sphere that stretches for unimaginable distances. Beyond the orbit of Neptune begins the Kuiper Belt, a junkyard of construction debris left over from the creation of the planets. Billions of icy blocks, dwarf planets, and rocks. But even that isn't the border. Further out is the scattered disk. And even further is the heliopause, the place where the solar wind collides with interstellar matter. That is where Voyager is right now. But even that is not the end of our prison. The real wall is called the Oort Cloud. It is a giant spherical bubble that surrounds us on all sides. It is the home of long-period comets, billions, trillions of icy bodies slowly drifting in eternal darkness. The boundaries of the Oort Cloud extend almost a light year from the sun. Think about it. A light year. Light, flying at a speed of 300,000 kilometers per second, takes a whole year just to reach the boundary of our domain. To truly fly out of the solar system, to leave the sun's gravitational grip, we need to overcome the Oort Cloud. Do you know how long that would take a modern spaceship? Voyager will reach the inner edge of the Oort Cloud only in 300 years, and to fly through it, it will take 30,000 years. 30,000 years. The entire history of human civilization, from the first cave paintings to the iPhone in your pocket, is about 10 to 12,000 years. We need to live through 3 such histories while our ship simply exits the fence. And that is just the exit. Beyond that begins the true abyss, the emptiness between stars. Let's talk about Proxima Centauri. That is our target number 1, the closest, most desirable star. There is even a planet there, Proxima b, which theoretically could be habitable. The distance to it is 4.24 light years. It seems small, 4 years, but that is 4 years for light. For us, material beings, this distance turns into eternity. If we send the fastest spacecraft we have right now, the Parker Solar Probe, accelerating it to a record 700,000 kilometers per hour, which is incredibly difficult to do moving away from the sun, the flight would take about 7,000 years. But the Parker probe is a small robot falling into the sun. A ship with people, supplies, and shielding would weigh thousands of tons. It is impossible to accelerate it like that with modern engines. A realistic forecast for modern chemical rockets is 70 or 80,000 years of flight. 70,000 years in a metal can. Imagine people living 70,000 years ago. They weren't even us in the modern sense. They were early Cro-Magnons just starting to leave Africa. They hunted mammoths with stone spears. They had no writing, no states, no wheel. Now imagine they launched a ship, and this ship has been flying through all of our history. It flies while the pyramids are being built. It flies while Rome falls. It flies while Columbus discovers America. It flies while we land on the moon. And now, 70,000 years later, it is still flying. It has only covered half the way. During this time, the crew inside the ship must not only survive, they must preserve their culture, language, knowledge, and mission goal. But that is impossible. In 70,000 years, they will forget who they are and where they came from. The language will change beyond recognition. They will turn into a tribe of savages trapped in a steel cave, worshiping the reactor as a deity. They won't even realize they've arrived when the ship finally reaches its destination. You might argue, we'll invent new engines, nuclear propulsion, ion drives, laser sails. Yes, theoretically, we can fly faster. We can shorten the trip from 70,000 years to, say, 100 years. That sounds acceptable. A human lifetime. But here we hit the second wall, a wall even scarier than distance. This wall is called the rocket equation, and it is the cruelest law of physics that puts an end to our dreams of the stars. Because in space, you have to pay for everything, and the currency here is mass. Konstantin Tsiolkovsky was a genius. He gave us the road to space. But he also wrote the sentence for all our long-distance travels. The essence of the equation is terrifyingly simple. To accelerate a ship, you need to throw something backward: fuel, gas, plasma. But to throw fuel, you first need to carry that fuel with you, and fuel has weight. That means to accelerate the ship, you need fuel. But to accelerate that fuel, you need more fuel. And to accelerate that extra fuel, you need even more fuel. It is a vicious circle, an exponential nightmare. Look at the Saturn V rocket that took humans to the moon. It was a giant tower 30 stories high. It weighed 3,000 tons at launch. Do you know what part of that mass was the useful payload, the ship and astronauts themselves? Just 1.5%. 98.5% of the rocket was fuel and tanks, just to lift those pitiful 1.5% to orbit and push them toward the moon. And the moon is right next door. It's our backyard. To fly to Mars and back, we need not 3,000 tons, but a monster the size of the International Space Station, completely filled with fuel, assembled in orbit. Now apply this to the stars. To reach Proxima Centauri in a reasonable time, say 40 years, we need to accelerate to at least 10% of the speed of light. That is 30,000 kilometers per second. If we use the best chemical engines we have to accelerate a 1-ton ship, the size of a car, to that speed, we would need more fuel than there are atoms in the entire observable universe. That is not a joke. That is math. Chemical rockets are useless for stars. Forget them. Okay, let's take nuclear engines, or thermonuclear. They are much more efficient. But even with them, the rocket equation continues to choke us. To deliver a small probe to the stars on thermonuclear thrust, that probe must consist almost entirely of fuel. The fuel-to-ship mass ratio would be in the thousands to 1. Imagine an oil tanker the size of Mount Everest with a postage stamp glued to its bow. That is what an interstellar ship looks like from a physics perspective. And that's just acceleration. Many forget that leaving is only half the battle. We also need to brake. There is no air in space, no friction. If you accelerated to 10% of the speed of light, you would fly past Proxima Centauri in a fraction of a second. You simply wouldn't have time to see anything. To stop, you need just as much fuel as you spent accelerating. That means at the start, you need to carry fuel for acceleration, plus fuel for braking, plus fuel to accelerate the fuel for braking. The mass of the ship grows geometrically. We can dream of antimatter, the most efficient fuel in the universe. Annihilating a kilogram of antimatter releases energy equal to the Tsar Bomba explosion. Ideal? No, because producing 1 gram of antimatter with modern methods costs trillions of dollars and requires all the particle accelerators in the world running for millions of years. We don't know how to store it. The slightest magnetic field error, and your ship turns into a flash of light, visible from another galaxy. But even if we miraculously find a way to get tons of antimatter, even if we build an engine that converts energy to thrust with 100% efficiency, we still hit a ceiling. Relativistic effects. The faster we fly, the heavier our ship becomes. As we approach the speed of light, mass tends toward infinity. The energy needed for acceleration tends toward infinity. We can never reach the speed of light. We can only infinitely approach it, burning stars for every extra kilometer per hour. The tyranny of the rocket equation tells us, stay home. You are too heavy to fly. But let's say we are stubborn. Let's say we built a giant ship, found magic fuel, and accelerated. We are flying at 20% of light speed. We conquered gravity and mass. And that is when space draws its next weapon. Because at that speed, space stops being empty. It turns into a shooting range where you are the target. We are used to thinking of space as a vacuum, as a place where there is nothing. But when you fly at relativistic speeds, the calm lake turns into a wall of concrete. The interstellar medium is filled with gas and dust. On average, there is 1 hydrogen atom per cubic centimeter. It seems like nothing. But at 60,000 kilometers per second, every single atom becomes a projectile. Impact with 1 hydrogen atom triggers a micro-explosion, releasing hard gamma radiation. Now imagine your ship flying through trillions of such atoms every second. The front of your ship will start glowing with radiation. The hull will be bombarded by a stream of particles with such energy that they will destroy the molecular structure of any material. But gas is only half the trouble. There is dust, microscopic grains of sand. On Earth, such a speck would land on your shoulder and you wouldn't feel it. But in space, at relativistic speeds, the kinetic energy of that speck equals the explosion of an anti-tank mine, or a tactical nuke if the speck is slightly larger. Impact with a pea-sized object at 20% light speed will instantly vaporize any ship. The impact energy would be equivalent to hundreds of Hiroshimas, and we can't dodge. Radars won't see a speck of dust at that distance in time, and even if they do, turning at that speed is impossible. Inertia would tear the ship apart. That means we need armor. We need a shield. Not just a steel sheet. Steel would evaporate. We need a shield hundreds of meters thick, preferably kilometers. Scientists propose using ice. Imagine a ship pushed by a giant iceberg. This iceberg takes the hits, evaporates, breaks apart, protecting the habitat module. But back to the rocket equation. An iceberg weighs millions of tons. To accelerate millions of tons requires infinite energy. We are trapped again. To survive, we need armor. To carry armor, we can't fly fast. If we don't fly fast, we never arrive. But there is an enemy even scarier than dust, an enemy that even an ice shield won't save us from. Cosmic rays. These are atomic nuclei accelerated by supernova explosions to speeds close to light. They are the universe's natural bullets. They pierce space through and through. On Earth, the atmosphere and magnetic field protect us. In interstellar space, there is no protection. Cosmic rays have such energy that they pass through the ship's hull like a knife through butter. They pass through the human body, tearing DNA chains, destroying brain cells, causing cancer and radiation sickness. Even worse, when a cosmic ray hits the metal hull, secondary radiation occurs. The walls of the ship themselves start glowing with X-rays. A crew flying to Proxima Centauri will receive a lethal dose of radiation long before they see the target. Their brains will degrade, their bodies covered in tumors. To protect against cosmic rays, we need an active magnetic shield. We need to create an artificial magnetic field around the ship with power equal to Earth's field. That requires giant superconducting magnets and a colossal amount of electricity, which means weight again, energy again, the rocket equation again. Space tells us there is shooting here. But let's assume we found a way. We created force fields. We built a ship out of indestructible future material. We solved the physics. And then we face a problem that cannot be solved by technology. The weakest link in any space program, ourselves. We are biological machines, complex, fragile bags of water, protein, and calcium. We are the product of evolution that took place in very specific greenhouse conditions. We are built for 1G gravity, for atmospheric pressure, for Earth's magnetic field, for a 24-hour day-night cycle. Remove just one of these factors, and we start to break. Look at astronauts. Without gravity, the body decides it doesn't need a skeleton anymore. Calcium is washed out of bones. Bones become fragile as glass. In a year of flight, a person can lose up to 20% of bone mass. The heart weakens. It doesn't need to pump blood up against gravity anymore. It shrinks, atrophies. Vision fails. Intracranial pressure rises and presses on the eyeballs, deforming them. Many astronauts return with irreversible vision damage. The immune system goes crazy. Bacteria in 0G become more aggressive, while our defense cells get lazy. Flying to the stars in 0G is impossible. We would arrive as jellyfish, unable to stand. That means artificial gravity, rotating centrifuges. But creating a centrifuge on a ship is an engineering nightmare. It has to be huge to avoid nausea from the Coriolis effect. If the radius is small, your feet will weigh more than your head. Blood will drain from your brain. You'll pass out, so the ship must be hundreds of meters in diameter. Again, a giant structure. Again, weight. Again, the rocket equation. But biology is just half the trouble. There is something scarier than the destruction of the body, the destruction of the mind. Psychology. Imagine the Earth effect. Astronauts say the most powerful moment is when you can cover Earth with your thumb. Everything you loved, everyone you knew, all human history hides behind your fingernail. But they saw Earth. It was nearby, blue, and saving. An interstellar crew will see Earth turn into a dot, and then disappear completely. They will be in total, absolute emptiness, surrounded only by darkness and stars that give no warmth. Isolation experiments on Earth have shown that even in a year and a half, conflicts, depression, and sleep disorders begin. But here, the flight is not a year and a half. It is decades or centuries. A closed group, the same faces every day, no chance to go outside, no chance to call home. The signal takes years, total disconnection from humanity. Psychologists predict the crew will go mad. Psychosis, paranoia, power struggles, religious cults. Humans are social animals, but we are not designed to live in a tin can in the middle of nowhere. We will tear each other's throats out. And this leads to the darkest scenario: generation ships. If we can't fly fast, we must fly long. We send a huge city ship that flies for 1,000 years. The first generation, the volunteers, die en route. The second, third, 10th generation is born, lives, and dies inside the ship, never seeing Earth or the new planet. This is a moral hell. What right do we have to condemn unborn children to life in prison? They didn't choose this mission. They are born hostages of their great-grandfather's dream. Who will they grow up to be? They will likely rebel. They will want to return, or they will forget the goal. Through 500 years, the ship will turn into a flying crypt filled with madmen or corpses. Biology and psychology are fuses built into us by nature. They say, don't go far from home, you won't survive here. But even if we create superhumans, genetically modified cyborgs who don't need gravity, don't fear radiation, and have their emotions removed, even they cannot defeat the last enemy. The enemy that makes any flight meaningless: time. Time and space has two faces, and both laugh at us. The first face is the weight calculation paradox. Imagine today we build a generation ship called Hope. It flies at 1% of light speed. It takes 400 years to reach Proxima. The crew says goodbye, goes into cryosleep. Hope departs. 200 years pass. On Earth, science has advanced. We invent antimatter engines that fly at 50% light speed. We build a new ship, Swift. It launches 200 years after Hope. But since it flies 50 times faster, it catches up to Hope in just 4 years. The crew of Swift overtakes the old, slow ship, waves at them through the window, and arrives at Proxima first. They colonize the planet. And 150 years later, Hope arrives. A decrepit, falling-apart ship carrying the degraded descendants of the first crew. They arrive not as heroes, but as museum exhibits, poor relatives from the past. Their sacrifice was in vain. This paradox tells us, don't fly now, wait, the future will be faster. But we wait, and technologies improve, and we wait again. Ad infinitum. We never fly because it is always profitable to wait for the next breakthrough. The second face of time is relativistic dilation. Suppose we did accelerate. We fly at 99.9% light speed. For the ship's crew, time compresses. Thanks to Einstein, a flight to the center of the galaxy takes them only a couple of decades. They arrive young, but on Earth thousands, millions of years pass. It is a one-way ticket. If you leave at that speed, you can never return home, because home no longer exists. While you flew, nations vanished, continents shifted, maybe humanity itself went extinct. You become a ghost, an artifact from ancient history. Your reports, your discoveries, no one needs them. When your signal reaches Earth, there is no one to receive it. Or technology has advanced so far that your discoveries seem like cave paintings. What is the point of exploration if you can't share the result? What is the point of a journey if you have nowhere to return? Space isolates us, not only in space, but in time. It separates civilizations into different time streams, so they never meet. That is why we have never seen aliens, not because they don't exist, but because no one can overcome these walls. Everyone is sitting in their solitary cells. Does this mean the end? Does this mean humanity is doomed to stagnate on Earth until the sun burns us? No. If we cannot go outward, we must go inward. If we cannot conquer outer space, we must conquer inner space. The deadlock in cosmic expansion is perhaps the best gift for our civilization. It forces us to stop wasting resources on meaningless attempts to smash our heads against the wall and pay attention to what we already have. In our solar system, there is enough energy and matter to build a paradise. We can dismantle Mercury and build a Dyson swarm around the sun. We can collect all the energy of our star, billions of trillions of watts that are now just flying off into the void. This energy is enough to create virtual worlds of incredible complexity. Why fly to a distant, cold, dead star, spending thousands of years on it, if you can upload your consciousness into a matrix the size of a planet where the laws of physics obey our imagination? Inside a supercomputer powered by the sun, we can create millions of universes. We can live thousands of lives. We can fly faster than light, use magic, create galaxies with a thought in virtual reality. The path of civilization is not extensive, seizing new territories, but intensive, complicating the inner world. Perhaps that is why we don't see aliens. They didn't die out, they just went online. They realized that the physical universe is a boring, cold, limiting desert, and they built their own, better universes at home. They sit around their stars, wrapped in Dyson spheres, enjoying eternity in a digital paradise, while we savages try to build a raft to cross an ocean of lava. Our future is not Star Trek. Our future is the Matrix, but without the evil machines. A matrix we build for ourselves as a shelter from the cruel reality of space. We will stay in the solar system, but inside this system, we will create infinity. Let's summarize. We dismantled the walls of our prison. We saw that physics, biology, and time conspired to keep us here. For some, this video sounds like a sentence. We will never fly to the stars. It hurts. It kills a childhood dream. But growing up is always about letting go of illusions. A child dreams of becoming an astronaut and flying away. An adult understands that they need to cultivate their garden. Earth and the solar system are our garden. It is huge. It is rich. It is beautiful. We have Mars, which can be terraformed for hundreds of years. We have the oceans of Europa and Enceladus. We have Titan with its methane rivers. We have the resources of the asteroid belt. We have enough work for millions of years ahead without ever leaving Pluto's orbit. We don't need to run. We don't need to look for a spare planet because we won't find anything better than Earth. Realizing that we are trapped should not frighten, but sober us. It should make us cherish every breath of air, every clean stream, every animal species we haven't destroyed yet. Because within a radius of 100,000 light-years, there is no other place where we could survive. The universe tells us, look, but don't touch. And maybe there is higher wisdom in that. Maybe we are not ready. A species that cannot clean up one planet should not spread to the galaxy like a plague. A prison? Maybe. But maybe it's not a prison. Maybe it's a nursery or a quarantine. And until we learn to live in peace with ourselves here, in our cradle, the door out will be closed. And when we learn, who knows? Maybe then we will realize that we don't need to go anywhere. Look out the window, look at the sky. It is black for a reason. That blackness is a wall that protects us from chaos. We are home, and we will stay home forever. And there is nothing wrong with that. Thank you for walking this long path of realization with me. It was a hard truth, but only the truth makes us free. Even if we are locked in the solar system, our minds are free to understand and accept it. Protect Earth. There won't be another one.